Hello student, today we are going to study the circular convolution. So there are many methods to perform the convolution of the signal. So in this presentation we are going to study the circular convolution by two methods, that is a concentric circle method and matrix multiplication method. As well as the circular convolution can be performed by using the linear method or graphical method, as well as circular convolution by DFT IDFT method. So let us start with this. Circular convolution. The circular convolution of two sequence requires that one of the sequence should be the periodic. If the both sequences are non-periodic, then periodically extend one of the sequence and then perform the circular convolution. Circular convolution can be performed only if both sequences consist of the same number of the samples. So this is the condition for the circular convolution. So the two signals contain same number of the samples, then only we can perform the circular convolution. If both signal samples not same, then same this make them same by adding the extra zeros. So if the sequence have the different number of samples, then convert the smaller size sequence to the size of the larger size sequence by appending the zero padding. So if the one sequence is small than the second sequence, then we can pad the required zeros to the second sequence and make them sequence same for performing the circular convolution. The circular convolution has the same length of the input sequences, whereas the linear convolution, the length is n1, that is first number of samples input signal, and n2 is the number of samples for the second sequence minus 1. So that is the for the linear convolution the output length is n1 plus n2 minus 1, and for the circular convolution the output length is the maximum of n1 comma n2. That means suppose the two signals have the samples 5 and 4. So first signal have the samples 5 and second signal have the samples 4. Then by performing the linear convolution you will get the 5 plus 4 minus 1. So means 5 plus 4 9 minus 1. So 8 number of samples can be available by performing the linear convolution. But at the circular convolution the output length will be the maximum of the n1 comma n2, that is maximum of 5 comma 4. So that is a 5 number of samples we will get after the performing the linear convolution. So method of performing circular convolution. So this is the first method, that is a concentric circle method. We can treat as a method 1, and it can be performed, that is the third signal, that is x3 of n is equal to summation n is equal to 0 to n minus 1 x1 of n into x2 of m minus n, that is equal to x1 of n into or convolved with the x2 of n. So these are the steps to performing the concentric circle method of, operation. So suppose there are two signals is given. So graph the or graph the n samples of x1 equally spaced points around the outer circle in clockwise direction. Sorry, in counterclockwise direction or anti-clockwise direction. So first sample should be placed on the outer circle in anti-clockwise direction in equally spaced points. So this is the first step. Second step, so these steps are cleared while we solving the examples. So let us consider first the procedure. In the step number 1 you have to do the x1 placed in this way in the outer circle in anti-clockwise direction in equally spaced points. Start at the same point as was done for the x1. So what which is the starting point for the x1? So in inner circle start with the same point and graph the n number of the samples of the x2 at the equally spaced points around the inner circle in the clockwise direction. So whatever the signal placed points in outer circle, it is in anti-clockwise direction, and inner circle spaced points is in the clockwise direction or in clockwise direction. So we considered as a clockwise direction as a negative direction, and anti-clockwise direction is a positive direction. So multiply the corresponding samples. So you will get the x1 as it is, and x2 of n is nothing but the minus x2 of n. So multiply the corresponding samples of the two circles and sum the products of the products to produce the output. Next, in the next step, rotate the inner circle, keeping the outer circle fixed by the one sample in the counterclockwise direction. So, in this step number 4, you have to rotate the inner circle in anti-clockwise direction by sample point 1. So again, multiply the corresponding samples on the two circle and sum the products to produce the output. Next, repeat this procedure until the inner circle first samples coincides with the first samples of the exterior circle again, and this completes the one complete rotation. So this is nothing but the concentric circle method. So in this method, the outer circle or x1 is placed on the outer circle in anti-clockwise direction, and x2 is placed on the inner circle in clockwise direction. Multiply the both circle points to produce the output, and sum to the produce the output. Rotate these steps again. Rotate the inner circle in anti-clockwise direction by the sample point 1, and again multiply the corresponding sample points of the two circle and sum the products to produce the output. Again repeat the uh, for the next step, that means repeat the internal circle in again one more sample point, again multiply them and to produce the output. So let us consider the one example. Perform the circular convolution of the two sequences, that is x1 is equal to 2 1 2 1 and x2 is 1 2 3 4. Here the sample points of x1 of n and x2 of n are the same, so you can perform the circular convolution directly. But if the sample points are not same, then uh, pad the extra zeros in the smaller circle required to make them same. So here the x1 of n is placed on the outer circle, and x2 of n is placed in the inner circle. So x1 of n is placed in anti-clockwise direction. So that is 2 1 2 1, and x2 of n is placed in on the inner circle in clockwise direction, that is 1 1 2 3 and 4, right? So multiply the both points, that is 2 multiplied by 1, that is plus 1 multiplied by 3, so 2 multiplied by 1 plus 1 multiplied by 4 plus 2 multiplied by 3 plus 1 multiplied by 2. So you will get the x3 of 0 is equal to 14. Now again rotate this inner circle in anti-clockwise direction by sample point 1. So you will get the one place in upward direction. So here the starting position will be start in the inner circle. So 1, 2, 3 and 4. Again multiply the both circle points. So that is 2 multiplied by 2 plus 1 multiplied by 1 plus 2 multiplied by 4 plus 1 multiplied by 3, that is equal to 60. Again rotate one more sample point, so you will get the one starting point here. So that is 1 2 3 4. Keep the outside circle as it is. So again multiply the points. 2 multiplied by 3 plus 1 multiplied by 2 plus 2 multiplied by 1 plus 1 multiplied by 4, so it is 14. Again shift this point to this point. So that is 1 2 3 4. Again multiply the points, that is 2 multiplied by 4 plus 1 multiplied by 3 plus 2 multiplied by 2 plus 1 multiplied by 1. So you will get the 60. So at the end you will get the output x3 of m is equal to 14 16 14 16. So output of circular convolution is maximum of n1 comma n2. So here n1 and n2 both are the 4. So the maximum samples, output sample will be, you will get the 4. Take the one more example. Here the x of n is 0, 1, 2, 3 and h of n is 2, 1, 2, 1. Sorry, 2, 1, 1, 2. So draw the x of n. So outer circle, so 0 in anticlockwise direction. Place the points of x of n in outer circle, that is 0, 1, 2, 3. And the next one is the inner circle in clockwise direction, that is 2. So here 2, 1, 1, 2. So in this next step, make this circle in anticlockwise direction. So that is 2, 1, 1, 2. Right. So multiply the all points. So 0 multiplied by 2 plus 2 multiplied by 1 plus 1 multiplied by 2 plus 3 multiplied by 1, that is equal to 7. Next again rotate the inner circle by one sample point, so you will get, so the starting point will be here of h of n, so it will become 2, 1, 1, 2. So multiply with the outer circle, so it is 0 multiplied by 1, 1, 2 multiplied by 1, 2, 2 multiplied by 2, 2, 4 and 3 multiplied by 1, so it is 3. So the output will, you will get the 9. Again rotate this point to this position, so you will get the new starting position is here, so that is 2, 1, 1, 2. So again multiplied with the outer circle, that is 0 multiplied by 1 plus 1 multiplied by 1 plus 2 multiplied by 2 plus 3 multiplied by 2, so you will get the 11. Next again new starting point will be here, so that is 2, 1, 1, 2. So multiply with the outer circle, that is 0 multiplied by 2, 2 plus 1 multiplied by 1, 1 plus 2 multiplied by 2, 2, 4 and 3 multiplied by 2, so it is 6. So you will get the 9 again. So finally you will get the output y of n is equal to 7, 9, 11, 9. So in this way you can perform the concentric circle method for the operation of the circular convolution. So the next method is the matrix method, that is a circular convolution using the matrix method. So in this method, the graphical method we have studied is a very tedious, because every time you have to draw the two circles and shift the new starting point and multiply that point and sum that product. So this is a little bit tedious. So especially when many samples are present, while the matrix method is very convenient, and this method is also again verified for the different linear convolution as well as the circular convolution. In this matrix method, one sequence is repeated via circular shifting of the samples. So this is the y of m is equal to x of n convolved with the h of n, that is equal to h of n convolved with the nx of n. So these are the output samples and this is the h of n. So h of n is first column is h of n. Again this h of n is shifted to this at the second column top. Again this h of 0, again h of 1 and circularly rotate it. Again h of n minus 2 is shifted to the third column top. So this previous column is as it is. Next h of n minus 3 is shifted to next and so on. So this shifting is up to your original sequence will be obtained. So this circularly shifted signal is multiplied with your second input sequence, and the output of multiplication is nothing but the circular convolution using matrix method. So let us take the one example. x1 of n is equal to 1, 2, 3, 1 and x2 of n is equal to 4, 3, 2, 2. Y of m is equal to x2 of n multiplied by the x1 of n. So here x1 of 0 is equal to 1, 1, x1 of 1 is equal to 2, x2 of 3 is equal to 3 and here n is equal to 4. So this is the y of 0, 1, 2, 3. So in this way you can shift the signal x of 0, x2 of 1, x2 of 2, x2 of 3. So this 3 will be shifted here. So again x2 of 0, x2 of 1, x2 of 2. Again this x2 of 2 will be shifted here. So x2 of 2, x2 of 3, x2 of 0 and x2 of 1. Again x2 of 1 will be shifted here. Again x2 of 2, x2 of 3 and x2 of 0. And after this shift, you will get your original sequence. So if the sequence is the four sample points, so you have to do the shifting 3 times. So after 3 times you will get the original sequence. And this is the first sequence x1 of 0 up to the x1 of 3. So output y of 0 to the y of 3 is equal to, this is your input sequence, that is x2 of n is equal to 4 3 2 2. Shift this sequence, that is 2 4 3 2. Again shift this bottom 2 to the top of the third column, that is 2 2 4 3. Again this 3 will be shifted to the fourth top column, that is 3 2 2 4. After this shift you will get the original sequence, that is 4 3 2 2. So multiply this sequence with your second input sequence, that is 1 2 3 1. So that is 4 multiplied by 1 plus 2 multiplied by 2 plus 2 multiplied by 3 plus 3 multiplied by 1. So in this way you will get the output 17 again. So in this way you will get the multiplication 17, 19, 22 and 19. So finally you will get the circular convolution output is 17, 19, 22 and 19. Again one more, compute the circular convolution of the following sequence and compare the result of the linear convolution. So you can perform the linear convolution. So this is the y of 0 to the y of 7. So here the two inputs what given, their samples length are not same. So 1 1 1 4 times 1 and 4 times minus 1. Here 0 1 2 3. Sorry, the samples length is same, so you can perform the metric operation. So this is the x of n. Shift the signal to the 6 times, 7 times, so you will get this matrix. And this is the h of n, that is multiplied matrix 0 1 2 3 4 3 2 1. So multiply these 2 points, so you will get this multiplication operation, and at the end you will get the output minus 4 minus 8 minus 8 minus 4 4 8 8 4. So this is the circular convolution by the matrix method. So you can use this same method, same sequence for the linear convolution. So this is the first sequence, that is 1 1 1 1 minus 1 minus 1 minus 1 minus 1, and this is the second sequence here, 0 1 2 3 4 3 2 1. So 0 multiplied by 1, so you will get the 0, 0 multiplied by 1 0. So this first line will be the 0. Next 1 multiplied by this 1, so you will get the 1. 1 multiplied by this 1, so you will get the 1. Again this 1 will be the, as per this your input sequence. Again 2, again 3, again 4, again 3, again 2 and again 1. So draw this kind of the dashed lines, so you can add the diagonally. So first input sequence is 0, second is 1, third is 2 plus 1 3, fourth 3 plus 2 5 plus 6, so you will get the 6 as output. So 4 plus 3 7 plus 2 9 plus 1 10. So in this way, by adding the diagonally, you will get the output, that is 0 1 3 6 11 10 11 9 4 minus 4 minus 9 minus 11 minus 10 minus 6 minus 3 and minus 1. So if you check the output of circular convolution and the output of the linear convolution, this is the second equation, these two outputs are different. So we can conclude that the result of the circular convolution and linear convolution are not same. So why the result of circular convolution and linear convolution is not same? So basically the circular convolution y of m contains the same number of samples as that of x of n and h of n. In previous examples, x of n and h of n have the 8 samples, but the circular convolution is given by the equation. It also contains the 8 samples because circular convolution output samples n is equal to maximum of n1 comma n2. So the both input sequence contains the 8 samples, so that's why the output of the circular convolution in previous example also have the contains the 8 samples. But in previous example, the linear convolution or equation 2, here the output samples are the 15, that is n1 plus n2 minus 1. So n1 have contains the 8 samples plus n2 contains the 8 samples minus 1. So 8 plus 8 16 minus 1. So it becomes 15, right? So the number of L is nothing but the number of samples in x1, m is nothing but the number of samples in h1. So the n is equal to L plus m minus 1. So 8 plus 8 16 minus 1, so it is a 15. So output of the linear convolution contains the 15 sample by this formula. So that's why the linear result of the linear convolution and circular convolution are not same, because linear convolution contains the maximum number of the samples. So how the question is what the how to obtain the same results from the circular and linear convolution. So for to obtain the same results from the both convolution, the following steps are used. So use the equation number 3 to calculate the n that means the number of samples contained in the linear convolution. Suppose take it is a 50. So by padding the by 0 padding, make the length of every sequence equal to the 15. So if you make the length of the every sequence instead of 8, if you make the 15 length, so you will get the, or you have to pad the 7 extra zeros in the x of n and h of n and perform the circular convolution. So whatever the result will be obtained by the circular convolution and linear convolution will be the same. So while performing the circular convolution, if you want the result of the circular convolution similar to the linear convolution, pad the extra zeros as per the output. Like suppose the input contains the 8 and 8, input samples contains the 8 and 8. So L plus M minus 1, so it is a 15. So and output contains the 8 samples, but you have to pad the 7 zeros in x of n and h of n and perform the circular convolution. So output will be similar, or result will be same as the linear convolution. Let us take the example of this. Suppose x of n is equal to 1, 2, 3, 4 and x2 of n is equal to 1, 1, 1. So obtain the same result as a circular convolution. Here x of n is equal to 1, 2, 3, 4 and h2 of n samples are not same. So add the one more 0 here. So triple 1, 0. Perform the matrix operation, linear operation, sorry, 1, 2, 3, 4 and 1, 1, 1, 0. So 1 multiplied by 1, so it becomes 1. 1 multiplied by 2, it becomes 2. 1 multiplied by 3, it becomes 3. And 1 multiplied by 4, it becomes 4. Again 1, 2, 3, 4. Again 1, 2, 3, 4 and 0. So add the diagonal 1, 3, 6, 9, 7, 4 and 0. So output will be 1, 3, 6, 9, 7, 4 and 0. So, so the here we will obtain the same result by using the circular convolution, and here the length of the linear convolution is 7, and if we have to make the same number of the samples in x of n and h of n equal to the 7, but the length is preferred in terms of the power of 7, so we will make the length of x of n and h of n equal to the 8 by doing the 0 padding. So your sequence will become, so 1, 2, 3, 4 and 4 more number of zeros, and here the 5 more number of zeros, and make it equal and perform the matrix operation. So these are the y of 0 to the y of 7. This is the first sequence 1, 2, 3, 4. Make the 7 time shifting, so you will get this shifted version of the signal. And the second input sequence is 1, 2, 3, perform the matrix operation. So you will get the output 136974000. So this output is similar with the linear operation or linear convolution output by using the zero padding. Next, circular convolution using the DFT and IDFT method. So circular convolution can be performed by using the usual DFT and IDFT formula. So take the endpoint DFT of x1 and x2. So x1 of perform the x1 of k and x2 of k. That means x1 of k is nothing but the DFT of x1 of n, and x2 of k is nothing but the DFT of the x2 of n. And determine the x3 of k by multiplying the points of x1 of k multiplied by x2 of k. And if you take the IDFT of x3 of k, you will get the output, which is nothing but the circular convolution output. So take down the one more example. So x1 of n is equal to 1, 1, 2, 1, and x2 of n is equal to 1, 2, 3, 4. So we know x3 of k is equal to x1 of k into x2 of k. But x1 of k is nothing but use the DFT formula summation n is equal to 0 to n minus 1 x1 of n e raised to minus j2 pi kn by n for k is equal to 0 to n minus 1. Here the n is equal to 4 for the first sequence. So x1 of 0 is equal to summation n is equal to 0 to 1. If you put n is equal to 0 here, you will get the x1 of n only, because e raised to 0 will become 1. So x1 of n is equal to 1 plus 1 plus 2 plus 1. So it becomes 5. Similarly, n is equal to 1. So x1 of n is equal to, sorry, k is equal to 1. So x1 of 1 is equal to summation n is equal to 0 to 1. Here k is equal to 1. So x1 of n into e raised to minus j pi n divided by 2. So put the n value from 0 to 3. So you will get the 1 minus j minus 2 plus j. So it becomes 1. Similarly, x1 of 2 is 1. x3 of 1 is x1 of 3 is equal to minus 1. So finally you will get the x1 of k as a DFT of x1 of n, that is 5 minus 1 1 minus 1. Similarly, perform the same operation for the x2 of k, that is summation n is equal to 0 to n minus 1 x2 of n e raised to minus j2 pi kn divided by n. So k is equal to 0, k is equal to 1, k is equal to 2, and k is equal to 3. So you will get the x2 of k is nothing but 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So perform the x3 of k by multiplying the x1 of k into x2 of k. So you will get the 52 minus 2j minus 2 comma 2 plus 2j. So you will get, after the x3 of k, take the IDFT of x3 of k. So you will get the x3 of n is equal to 1 by n summation k is equal to 0 to n minus 1 x3 of k e raised to positive j2 pi kn by n. So put the values for n, that is 0 to n minus 1, and perform the operation. So after performing the IDFT, you will get the 13, 14, 11, 12. So this method you can compare by using the simple matrix method. Thank you.